we're going to be working with our exponent rules, but our exponents are now going to have fractions in them. Which means all of our exponent rules still hold true, but now we're going to have to deal with it in terms with fractions. We're also going to look at it in terms of what are called nth roots. For example, the easiest thing to talk about when we're looking at what we call an nth root Okay. Now, an nth root, this just says the square root of 9. We all know the square root of 9 is 3. But right now, I'll come back to the whole plus minus deal here in a second. What you don't know is that there is a value of n, what I'm calling an nth root, that's not shown for a square root. That value is a 2. There are a lot of things in math that we get lazy about. Logarithms. If you look at your calculator, there's a button that says log. When you have a log, and we'll talk about this when we come back from second semester right off the bat, a logarithm has a standard base of base 10. So if you take the log of 3, that means it's log base 10. We just don't write the 10. Okay? It's just like the idea of not putting a 1 in front of a variable. Do you need it? No. So what happens here is that you get this nth root for a square root. The power of the value of n is going to be 2. It's just not shown. So another way that we can write this is going to be the square root of 9 can be rewritten in terms of an exponent. It is 9 to the 1/2 power. Right? Some of you might have seen that before, some of you may not have. Excuse me. We're going to get these values of these nth roots. Any nth root value of a. This n value always goes to the denominator. So it's a to the 1 over n. Will work every time. Which means we can introduce higher degree roots. For example, the 4th root of 81. The 4th root of 81 means what are 4 numbers that you multiply together to get you 81? 3.
Times 3.
Right.
I said the first. No, you didn't.
So the 4th root of 81, if you see here, I'm saying it's the 4th root. 4th, 81 to the 4th is 3. Okay. Now, there are going to be times that you will not be using a calculator, which means some of these roots you're going to have to be able to figure out in your head. You'll be pleasantly surprised that it's not that difficult. If there are ones you have to approximate and work yourselves through, on your calculator, if you hit the button that says math, once again, convenient because it's a math class, tying that conversation back together. You hit math and it's option 5 once this thing loads.
How old are your kids?
Going to be 7 and 4 in February. Math 5. You get to change your root here. Pretty easy to work with if you get to use a calculator. Even if you had one of the dumb calculators, some of the dumb calculators have that X root button above one of the other functions somewhere. It looks the same. So back to this. Excuse me. We get a couple a couple rules to these. What I want to do is talk about when you have to worry about the plus minuses. Generally speaking, when you take a square root over an equal sign, that's when you have to worry about your plus minus, because you're taking it to both sides. Okay. We're going to write these things down, because these are just the rules for the roots. I'll show you the rule and I kind of write you an example here in a second. What this is saying is that if your nth root is odd, like cube root, 5th root, 7th root, and so on, there's only going to be one real answer. Okay. Pretty easy one to look at. If it is the cube root of 8, well, that's 8 to the 1/3, which is 2. What that's saying is that it has to be positive 2. Because 2 times 2 times 2 is positive 8. What happens if it was the cube root of negative 8? What would you get? Negative 2. So you can have negative answers for nth roots if if the nth root winds up being odd. Okay, it does work out. Next one we look at here, if n is even, this is when you have to worry about the plus minus. So if you're taking a square root over an equal sign, if you're taking a fourth root over an equal sign, or so on, and you knew this rule from a long time ago, anytime you have a square root over an equal sign, when you solve that out, you have to write plus minus. For example, if you had to take the square root of, I don't know, 1/3, bless you, you would get x equals plus or minus the square root of root 3 over 3. Familiar, maybe? Did mark that wrong on me yesterday, but it did mark a whole lot wrong about plus minus. You know what I'm talking about now?
I got it.
Question number 2.
Was it X and X?
Oh, yeah.
If what is the square root of 0?
The
Hi.
ghost is here.
What's the square root of 0?
0.
What's the fourth root of 0?
0.
What's the eighth root of 0?
0.
What's the 10th root of 0?
1.
What's the 0th root of 0?
0.
It doesn't exist.
That's what, yeah.
I'm just making stuff up. Basically, the idea here is if you take the square root or any root that is even of 0, it is always 0. Any even root of 0 will be 0. You knew that. Excuse me. Even when you get in with the odd stuff, we don't talk a lot about it because it gets to be weird, but I think there's only one last one. This is just to figure out how many reals. And then the last one, if you're trying to take the nth root of a negative number, for example, what's the square root of negative 4? Is that real? No. So this is just saying that you're not going to have any real roots. You already knew that because you've done that. This is an example of saying, what is the square root of negative 4? Well, you'd get plus or minus 2i, but we're talking about in terms of real. You just don't get a real root. Okay. Just like on other problems where you had vertical asymptote, if there was a vertical asymptote at the 0 of the denominator, it had to be the real 0 of the denominator. So if I happen to have, I don't know, x squared plus 4 in the denominator, would I have a real 0? No. So it wouldn't have a vertical asymptote. Little things like that. Same basic principle. If you guys just remember the idea about number of roots when you have a cube root or a square root, you can extrapolate that same pattern with that. What is extrapolate? You use it again for any even or odd root. It works. Okay. It works just cleanly. So now what we're going to look at is how do we. Oh, that's boring. We can do that. Let's look at the actual rules. No, I've known that. Yeah, it depends where I'm comfortable. Yeah, it depends how I feel.
If A is greater than, or A is less than, then there's no real reason.
Anyway, back to this. So here's what happens. One of the first things we learn, or we start working about with fractional exponents. If we have a to the m over n, what this means is that the value in the denominator will always be, after we put our feet down, will always be the nth root. It always goes to the root, and then everything else is raised to the power. It's root raised to the power. Denominator raised to the numerator. Okay? It will always work that way. It's a nice, clean way of going. Sir,
Does it not reduce?
what do you mean reduce? Are you shrinking something?
Like, I mean, if you
The
have
kids.
like 3 over 2, does it become a to the, like, does it just become a? Or-
No, I thought somebody was at the door. That's what you were saying. Sorry.
No, like Honey, I Shrunk the Kids.
No, what'll happen is you will get fractions that will simplify from time to time, but we'll get to that as they come up. But there are order of operations that are thrown. If I'm looking at that, you guys all see how you've got parentheses raised to an exponent? What would you take care of first? The parentheses. So yes, you can simplify something if possible, and we'll get to that. Same idea here. If any exponent is unhappy, just make the exponent happy right off the bat. Works the same with fractional exponents. If a fraction is unhappy in the numerator, it'll be happy in the denominator. If a fraction is unhappy in the denominator, it'll be happy in the numerator. Let me show you an example. 9 to the 3/2. When I'm written in fractional exponents, what I want to do is rewrite it as an nth root. I want to put it in terms of square roots because those are easier for me to think about because I know what the square root of 16 is and things like that. So what I do is I rewrite it. 9 to the 3/2 is the exact same thing as saying the square root of 9 cubed. I just don't put the 2 in front of the root because it's not needed. Okay? You can write the 2 there, it doesn't matter. But 2 is my nth root, 3 is my exponent. Order of operations tells me to take care of the parentheses first. What's the square root of 9? What's 3 cubed?
27.
Kobe.
That was nice.
I think 27. Okay. Just using order of operations.
First outside, inside class.
32 to the negative 2/5. Is that happy? No. Make them happy. What's the nth root then? 5. So this becomes 1 over the 5th root of 32 squared. So now you have to think about, what do you think 5 numbers that are exactly the same that you multiply together, plus you're going to get you 32. 2. So what's the 5th root of 32? 2. What's 2 squared?
4.
So therefore, 32 to the negative 2/5 is
1/4.
done. Sir,
Would you just switch it to the number under 1 as a fraction the denominator of the exponent was negative as opposed to the numerator?
Either one, because when you have a fraction, anytime a fraction is negative, it doesn't matter if it's numerator or the they just flip them. Okay. Let's look at one with a negative value. What are three numbers that you can multiply together to get you -8? -2. Then what's -2 to the 5th power?
-32.
Done. Works the same. And it's okay to get negative value here because both the nth root is odd and the power is odd. And it works.
What?
Okay? And it'll work.
Failed.
Not so scary?
No.
No, give us some hard ones.
No,
Let's
don't.
not.
Just you wait. Just you wait and see.
I still don't even understand it.
Are we going to use exponent fractions with variables as
Yeah.
a fraction?
Oh, variables as a fraction?
Yeah.
No, not. We won't have variables. We won't
So
have
like
variables.
m won't equal x?
No, I should say this. We shouldn't have. We won't have exponents with variables until we get to logarithms,
Oh, okay.
because that's how you solve that.
Yeah.
Okay. That's boring.
I'm sure if you had the choice, it would be very much.
Let's solve an equation with an nth root. Either one. So if I have 2x to the 4th, 2x to the 4th equals 162. What do you think you're gonna do first?
Divide each side by 2.
Good. So we divide both sides by 2.
Correct.
Now I get x to the 4th is 81. And then I can take the 4th root. Now remember, what I'm doing here with this exponent is I'm taking the 4th root of both sides. But if you want to think about it in terms of raising it to an exponent, it's the same thing as saying, move this down, take it to the 4th power. Because, correct. Power to power, you would multiply. 4 times the 4th is? You can't come in until you answer this question. What's 4 times the 4th?
Did you say, I don't know?
Did you just try to wipe off the smile face?
Drawing a tear.
It means the same thing. Or you can say the fact that you're going to take the 4th root on both sides. So, what's the 4th root of 81? 3. Now, I just took an even root over an equal sign. What do I have to put? Plus minus. Anytime I take an even root on both sides of an equation, I'm always going to have plus minus in there. Okay? What do I do on the other side? Take the cube root. Good. So I take the cube root on both sides. What's the cube root of 10? Cube root of 10, exactly. I cannot simplify that whatsoever. So I leave it. I don't care about decimals. Decimals are stupid.
Yep.
How do I get x by itself?
Decimals are just like.
Why was not the cube root of 10 written as plus minus? Because it's odd. It's an odd root. It's an odd nth root. When you have an odd nth root, it's always the same sign. When you take it, and this is a good thing to remember, whenever you take an odd root on both sides of the equation, your sign stays the same as it was to begin with. Whenever you take an even root over both sides of an equation, you will always get plus minus. All right. Odd roots stay the same. Even roots go plus minus when it's over and equal. All right. Oh wait, these are easy. Solve those. What's 8? Why is it not plus or minus 5? What's 9?
9 is
Negative
negative
one.
1.
What's 10? What's 11?
Plus or minus 9.
Whew.
Mr. Murphy, can you please make the problems easier? These are so hard.
Sure.
Thank you.
No.
Oh, these look
No,
better.
hold on,
Thank you.
wait.
Oh, there you go.
Oh, a little loud there.
Okay.
Still rocking out with the semi-nasal here. What would you do?
Times that by 7. I'm not sure what you do.
So what do you do first? Square both sides. And the reason you square both sides is because this is the same as 9 equals x over 7 to the half power. And then you square it. So 81 is x over 7.
X equals A over.
What? Oh, you want me to start over? Okay. How do you undo square rooting? What is the inverse operation of the square root? Square it. So? Square it. What's 9 squared? And then how do you undo divide by 7? You should be able to do 81 times 7 in your head.
563. 567.
I thought it was 63. I'm like, whoa, I'm not very bright today. Classic Murphy getting the math wrong. It's convenient.
Is that plus minus?
No, because you're squaring, there is no plus minus. When you square root, you gotta worry about plus minus. Okay. So in this case then, let me give you some problems. This is 7-1. It's all uploaded now. I think it's page 404. I think it's 20 through 30 evens. And then
That's it?
51 or something or up there. I forgot.
Grab.
Every little problem comes over.
Sure. Yeah, I like it.
$53 to $61. Okay. So for the two yabos that were out, nth roots. An nth root is a to the 1 over n. If you have an nth root raised to a power, it is a to the m over n. Because what you get here is, if you simplify that out, you get a to the 1 over n to the m, is what gives you a, using your exponent rules, power to power stuff. And that's basically all it was. That's it. What is it? Oh, 30 through 40, thank you. All right, so 30 through 40, sorry guys. I knew it was one of them. Yeah, 30 through 40, my bad.
How about we just do?
Can you talk to me?
How about we just do 30?
I don't care what you do, but you know. Tomorrow we're gonna spend tomorrow and Friday the bulk of it working on 7-2. 7-2 is gonna be all the exponent rules again thrown in with fractions, which means we have to add, subtract, multiply, divide without the aid of a calculator. What, this stuff? No, we'll finish this before we're done.
So we have another.
Probably.
We have another quiz as well, because I don't get my grade.
I don't have that many days left.
Oh, you got your
I will try to have it finished. I'm still trying to, I gotta finish grading your guys' stuff. I got pre-calc to grade. I got a couple of geometry stuff. I got a lot of tests this week, so. I'll PDF it, and as soon as I get it done, I will PDF it and email it out. So it may not be, it might be Saturday morning or something like that before I skip town, so, but I'll get it to you guys. Yes. What, so are you implying that this job's easy?
Because he has to teach kids like you how to do that.
Shifty, anytime you want to smack him, I'm not paying attention.
Oh, I know.